All right, now we are looking at the solutions video for assignment 1.04, assignment number 3. So it's the same concept we've been working with, but much more complicated problems. So in this case, we've got our k to the 12 plus 19k to the 6 plus 88 over 5k to the 8 plus 40k squared. We are going to want to simplify this as much as possible. So we'll start with transferring it to the whiteboard. So once we've made note of the factors we are working with, we are going to do everything that we can to factor them completely. So in our first one, even though we're not used to working with 12s and 6s, we have the proportion of 2, 1, 0 in our exponents again, which means we can treat this as a quadratic, where the variable is just k to the 6 instead of x. So looking for numbers that multiply out to 88 but add up to 19, we get k to the 6 plus 8 times k to the 6 plus 11. With our denominator, we can factor out a common factor of 5k squared, which leaves us k to the 6 plus 8, which will conveniently cancel in just a moment. Our numerator here, we have a k squared times a k squared minus 6. And now this last denominator is going to be a little more complicated in terms of factoring things out. What we are looking for are factors that multiply up to 33 and subtract to give us 9, but with denominators that multiply out to 12. So we can go to the quadratic equation formula. We have a number of approaches here. Again, treating it as treating k to the 6 as our variable rather than just k. And noting here, there's actually a mistake in the way I transcribed it. That was not a 12k squared. That was a 2k squared, which makes a fairly substantial difference in trying to factor things out here. So recognizing that 11 is a factor of 33, and working under the hope that we're going to be able to cancel this other term, I was able to show that this factors to 2k to the 6 minus 3 times k to the 6 plus 11. That gives us a negative 3 plus 22, or a plus 19 for the cross term, negative 33, and a positive 2. Now we do our cancellations. This k squared cancels with this one. K to the 6 plus 8 cancels here. K to the 6 plus 11 cancels here. So ultimately, this reduces to k squared minus 6 over 5 times 2k to the 6 minus 3. So this will be our final substitution. So that is our first one down. Now, for this one, we want to simplify the following rational expressions, or multiply the following rational expressions, and simplify the result. Notice that we have two variables involved here. We have both x's and n's. So again, it's going to make things more complicated, but certainly not impossible. All right, so we have our problem more carefully transcribed than our last one was. Just give it one more check. And yes, that does all check out. So now we can factor this. Our first will factor as x minus 4n times x minus n. This will give us the negative 5xn that we have here. I'm going to factor out a negative 3 from the denominator, no, sorry, I'm just going to factor out a positive 3, which will leave us with a positive x and a negative n. And I'll just write those terms in the other order. That will give us our first cancellation. Now over here we have a common factor of n and n alone. So we have x squared plus 16n squared. And that is divided by 12n cubed. So one of these n's cancels with one of those n's, leaving us with an n squared. So let's change color on that, so we see what was canceled out and what was already there. So this ultimately leaves us with x minus 4n times x squared plus 16n squared all over 36n squared. And we will submit and check this, double checking we have everything transcribed correctly. Looks good. Now this is a slightly different problem. Here we have to solve for b. So what is the polynomial expression we need in b to completely cancel everything out? So again, we start by transcribing the problem to our workspace. So now that we have it transcribed, our next step is to reciprocate our right-hand term, because division by a rational expression is always multiplying by the reciprocal, just like it was with dividing by fractions. And on the left-hand side, we can already start to do some of our factoring. So two numbers that multiply out to 27 but add up to 12 would make this n plus 3 times n plus 9. And in our denominator, we could cancel or factor out the common 3n squared, which will leave us with an n plus 3. Our right-hand denominator has a common factor of 2n. So if we rewrite that, having pulled out that common factor of 2n, we are left with n plus 9. This means we're going to have our n plus 3's cancel and our n plus 9's cancel. Which leaves us to say that b over 6n cubed is 1, where the 6n cubed comes from combining the 3n squared with the 2n. That is true if and only if b itself is also equal to 6n cubed. So b here is 6n cubed. And now, in our final question, we have to multiply the following rational expressions and simplify the result. Again, we start by transcribing to our workspace. Now that we have it transcribed, we can start pulling out common factors. Our first numerator has a common factor of 3, which leaves us with a 5z minus 6. And this denominator is a difference of perfect squared pattern. That's a 6 minus 5z times a 6 plus 5z. Not quite exactly what we have here. It's off by a sign. So I'm going to do what most mathematicians do when they see that things could have been better. I'm going to pretend I was brilliant and saw that from the beginning and factor a negative 3 out of the top, which leaves us with a 6 minus 5z, which then cancels quite nicely. Now, with our right-hand side, it's a little bit different. Here we don't have the difference of perfect squares, we have the product of perfect squares. This is what we get from 6 plus 5z squared. So again, we get some cancellations. One of these terms cancels with that squared. And in our denominator, we pull out a common factor of 9. And we have z squared plus 4. So this will now simplify to negative 3 times 6 plus 5z over 9 times z squared plus 4. This is our final simplification. So we carefully check to make sure it has been correctly transcribed. We have a negative 3, 6 plus 5z over 9z squared plus 4. And we have gone wrong somewhere. So we have gone wrong because I neglected to simplify the 3 over the 9. So, yes, we were on the right track, but we were not fully simplified.